Okay, let's now configure the second lifecycle hooks that will pause the instances before termination. Once paused, we will take a snapshot of the EBS volumes before allowing termination. For this, we will use a Lambda function to do the snapshot. Lambda is an AWS service that allows you to run code without provisioning servers and is often referred to as serverless. So, for everything to work, the Lambda function will need permissions on the EC2 service to snapshot a volume. So, we will need an IAM role to grant Lambda the necessary permissions. Then, we will create an event bridge rule that invokes the Lambda function when an instance termination event occurs. Event bridge is a service that allows to integrate a producer and a consumer of events. So, there are three elements to configure: an IAM role, the Lambda function, and the event bridge rule. So, let's start creating the IAM role. The first step is select again the service that needs permissions. In this case, Lambda. Next, we need to attach permission policies or documents that contain the required permissions. Let's attach a policy called EC2 Full Access. This document provides full access to the EC2 service. For our configuration, we do not need full access again, but it is easier to use a pre-configured document for a lab environment. In a production environment, be sure to grant only the necessary permissions. Moving on, I will name my role as EC2 Full Access and create the role. Now, it's time to create the Lambda function. From up here, I search for Lambda and enter here. Once inside, we click on Create a Function and provide a name like snapshots_EBS. For the execution environment, we are going to use Python. Next, we need to provide permissions to the Lambda function. So, I expand down here, select Use an existing role, and choose the newly created role. Once all of this is done, we press Create Function. By doing so, it will take you to the editor, and here, we can provide that function to use. So, I'm going to remove the default code and insert the required code. Then, this code gets the instance ID of the event bridge event that we are going to configure. Then, it enumerates the volume of the instance and the snapshots. After inserting the code, we press the deploy button, and the Lambda function has been created. Now, it is time to create the event bridge rule that will invoke this Lambda function. So, we look up here, event bridge, and we enter there. Once here, we click on Create Rule. We will give it a name such as EBS_rule. Below, in the rule type section, we are going to use the default selection rule within event pattern. In the next step, we will leave all this as is and in creation method. We will select Use Pattern Form and in the Event Pattern section, we will set the event source as AWS Services. We look for auto-scaling in the list. In Event Type, we will select Instance Launch and Termination. Next, we will select the specific instance events and configure them as EC2 instance terminate lifecycle action. This will cause the rule to be invoked when an EC2 instance in the auto-scaling group is being terminated. Then, we select the auto-scaling group we have created and press Next. Here, we have to select a target, in this case, to invoke the Lambda function, and we will select the function we have just created. Next, I will not add tags for now, and finally, we review the configuration and click on Create Rule. With this, we have created the necessary elements. That is the IAM role, the Lambda function, and the event bridge rule. Now, it is time to create a lifecycle hooks to intercept the instances at the time of termination. So, let's go back to the EC2 service and the auto-scaling groups. This is the auto-scaling group we used before, and it has one running instance and a desired and minimum capacity of 1. So, Let's go to the Instance Management tab and create the other lifecycle hook. Let's call this one My Second Hook. This name does not have to match the name I provided in the script because this lifecycle hook is not being used by the script. For the lifecycle transition, I will select Instance Terminate because we want the lifecycle hook to intercept at the time of termination. We will set the timeout to 60 seconds, and we can set the default result to continue. Then both continue and abandon will allow the termination to continue. So, it doesn't matter what we select here. With that done, I'll click Create, and it's done. Then, when a termination event occurs, the lifecycle hook will pause the termination. This is when the event bridge rule will invoke the lambda function. The lambda function will create a snapshot and then allow the termination to continue. So, let's try this. I'll change both the desired and minimum capacity to 0, which will cause a termination to occur. I'll click Refresh, and we should see the changes in the Instance Management tab. We can see that the instance is terminating. It has moved to the terminating wait state, which means it has been intercepted by the lifecycle hook, and now the lambda function will create a snapshot of the EBS volume. After creating it, the instance will be able to terminate. So, let's update here. After waiting a few seconds, the status has changed. Now it has gone to termination procedure, and now the instance will be terminated. After waiting a few seconds, the instance has exited the termination procedure state, so we have no more instances running. We can confirm this by going to Instances. And indeed, we can see that we have no more running instances. And to verify if the snapshot was created, we can go to Snapshots. And here we can see that it was created by the lambda function. So, this is how lifecycle hooks work. Make sure to delete your auto-scaling group, your EC2 instances and snapshots to avoid unnecessary charges.